Hello everyone. So in previous lecture, we discussed about sensitivity. In this session, we will discuss the basics of Laplace transform that is required in our control system syllabus. So first, let us discuss some basic signals. Then we will discuss the Laplace transform of the basic signals. First we have a step signal, then we have a ramp signal, third is impulse signal, and last is parabolic signals. So we will discuss each signal and its Laplace transform as per the required in control system. The detailed discussion of Laplace transform we will study in the subject signals and systems. Here we will study only as per our requirement in control system. So let us start with the first signal, which is the step signal. So the step signal, it is denoted by a u of t, where a is nothing but the height or magnitude of the signal. So in step signal, the coefficient is nothing but the height or the magnitude of the signal. So as you can see, this is a basic u of t signal and it is plotted with respect to the time period t. Here we can say for t is less than 0 means this side, that is nothing but the left hand side of the origin, there is no any signal present. For t greater than or equal to 0, we have a step signal and its height or magnitude is a. So mathematically, we can write u of t as, we have a signal aut and it is given by a for t greater than or equal to 0 and it is 0 for t is less than 0. So it is very important to know how to write a signal in mathematical form. Now it is important the value of signal aut at t is equals to 0, we have said it is nothing but a, as the sign is equal to or greater than. So we are saying at t is equals to 0, aut is nothing but a. Now if you observe properly, at t is equals to 0, we have a discontinuity or a sudden change. This part is the discontinuous part, or you can say it is a sudden change. Now let us discuss about this part. So as I told you, at t is equals to 0, we have a discontinuity, or you can say there is a sudden change. For t less than 0, the signal is 0, and for t greater than 0, the signal is a and it is till infinite. But at t is equals to 0, there is a sudden change or a discontinuity in signal. The signal rapidly goes from 0 to a at t is equals to 0. So at t is equals to 0, there is a discontinuity or a sudden change in the signal. And the value of step signal at t is equals to 0 can be found using the Gibbs phenomenon. Now let us see how to find the value of the signal u of t at t is equals to 0 by Gibbs phenomenon. So for u of 0, the formula is u of 0 minus plus u of 0 plus upon 2. So if you substitute the value of u of 0 minus, the value of the signal just before the origin, it is 0, and the value u of 0 plus, the value just after the origin, it is a upon 2. So the value of u of 0 is nothing but a by 2. This is an important thing, the concept of Gibbs phenomena, that is the value of step signal at t is equals to 0 is a by 2. It is valid only in signal and systems, that too in the topic Fourier transform, and we do not use this concept in control system. In control system, the value of step signal at t is equal to 0 is nothing but a and not a by 2. So this is an important concept you should know this concept. So with this basic understanding, let us go to the time shifting of a step signal. So now I have a signal r of t, which is nothing but u of t minus a. So t minus a is a delayed version of the basic signal u of t. So this is the delayed version or the delayed signal as compared to u of t. U of t minus a, the signal starts at t is equals to a. So mathematically, I can write the signal r of t, which is nothing but u of t minus a. It is given as u of t minus a, it is 1. The magnitude or the height of the signal is given as 1, and it is for t minus a is greater than or equal to 0, and it is 0 for t minus a is less than 0. I can also write this equation as u of t minus a, it is 1 for t is greater than or equal to a, and it is equal to 0 for t is less than a. So both these equations are correct. So in signal system, we call this as right shifted signal. Now let us study the next shifting, which is nothing but the left shifting, and we have a signal r of t, and it is given by u of t plus 1. It is the advanced version, or it is the advanced signal with respect to u of t. Here the signal starts at t is equals to minus a. So if you want, you can find by t plus a is equal to 0, and it is t is equals to minus a. So the signal is starting from t is equals to minus a. So mathematically, we can write r of t, which is nothing but u of t plus a. It is given as u of t plus a, it is 1. The magnitude or the height of the signal is 1 for t plus a is greater than or equal to 0, and the signal is 0 for t plus a is less than 0. Here also I can write this as u of t plus a is 1 for t is greater than or equal to minus a, and it is 0 for t is less than minus a. So both these equations are correct. You can use any equations as per your convenience. So this was the basic understanding of a step signal. Now let us see the Laplace transform and its properties of a step signal. So the Laplace transform of step signal u of t is nothing but 1 by s. Here we are not going in the derivation of how the Laplace transform of u of t is 1 by s. You will study the Laplace transform in detail in the subject signals and systems. Here we will discuss only the part which is required in our control system. So the Laplace transform of step signal u of t is 1 by s. Now the next property of Laplace transform is time shifting property. Now consider I have a signal x of t in time domain, and the Laplace transform of this signal x of t is nothing but x of s. The Laplace transform converts a signal in time domain to s domain. So now let us see the time shifting property. Now if you have the same signal x of t and it is time shifted, you will get x of t minus t naught. The signal x of t is shifted by minus t naught, and the Laplace transform of x of t minus t naught results in exponential, that is e raised to minus s t naught. So the simple way to remember this property is that time shifting in t domain, which is nothing but the time domain. Here you can see there is a time shifting in time domain. So the time shifting in time domain results in exponential in S domain, and the important thing is with same sign. Now let us discuss what do you mean by with same sign. Now here the time shifting is x of t minus t naught. So the time shifting will result in exponential, which is e raised to. Now the shifting is done by minus t naught. So here you have to write minus s into t naught. So with this property you can say similarly for the step signal is shifted by minus t naught, and the Laplace transform of the signal is e raised to minus st naught upon s. We know the Laplace transform of step signal u of t is 1 by s, and you have the shifted version of the step signal u of t minus t naught. So it is, first you have u of t, so the Laplace of u of t is 1 by s, into, then you have the shifted version, the time shifting property, and we know time shifting in t domain results in exponential, which is e, with same sign, so sign is minus, so minus s into t naught. We will get, it is nothing but e raised to minus st naught upon s. So this was a simple time shifting property in case of step signal. So let us now go to the third property, and it is called shifting in S domain. So again you can consider a signal x of t in time domain, and the Laplace transform of x of t is nothing but x of s. Now if you multiply the signal x of t with an exponential e raised to s naught of t, then we get x of s minus s naught. So a simple way to remember this property is that exponential multiplication in time domain results in shifting in S domain and with opposite sign. Now let us see what do you mean by opposite sign. So you have x of t here, the Laplace transform of x of t is x of s, so we have written x of s. Now this x of t is multiplied by an exponential signal e raised to s naught of t. The sign of s naught is plus, and we now studied exponential multiplication in time domain results in shifting in S domain with opposite sign. The sign of S naught was plus, and in S domain with opposite sign it is minus S naught. Similarly, we can use the shifting in S domain property with respect to u of t. I have a signal u of t and it is multiplied by an exponential signal e raised to S naught of t. So the Laplace transform of u of t into e raised to s naught of t is 1 upon s minus s naught. We know the Laplace transform of u of t is 1 by s, and with the help of multiplication u of t is multiplied by e raised to s naught of t. The Laplace transform will be Laplace of u of t. Laplace of u of t is 1 by s, and exponential multiplication in time domain results in shifting in s domain with opposite sign. Here the sign of s naught is positive, but here it will be negative of s naught. So this was again the basic property of shifting in s domain. Now let us directly see some important Laplace transforms. At fourth number we have sin omega naught t u of t. The Laplace transform of sin omega naught t u of t is omega naught upon s square plus omega naught square. The fifth is cos of omega naught t u of t, and its Laplace is s upon s square plus omega naught square. These both are the important formulas of Laplace transform. Again, I am telling you, we are not deriving the formulas, as you will discuss the derivation in detail in the subject signals and systems. So next formulas we have e raised to minus at sine omega naught t u of t. Since there is a multiplication by exponential signal, we will be having the shifting. So the formula of e raised to minus at sine omega naught t ut, its Laplace transform is omega naught upon s plus a whole bracket square plus omega naught square. Then we have e raised to minus at cos of omega naught t u of t. Its Laplace transform is s plus a upon s plus a whole bracket square plus omega naught square. So this was a basic study of step signal and its important Laplace transforms with the properties. So in next lecture, we will solve some basic questions on Laplace transform of step signals.